All right, guys. So today you're going to take a look at solving differential equations using the indefinite integral. So basically what we're going to be doing is using this initial condition here once we've gotten our actual f original function. Okay, so let's get started. We know that f prime is this. So if this is the derivative, then if I take the indefinite integral of f prime, that should give me my original function, right? So I'm just going to separate this integral, and then I'm pulling out the constants as I go, okay? Dx and I'll leave that and integrate that constant, okay? So when we do this, we're using the reverse power rule again. That's x n plus 1 over n plus 1 plus c, right? So n is just always going to be our exponent. So keep the 3 on the outside. We've got x 2 plus 1 over 2 plus 1 minus 4x 1 plus 1 over 1 plus 1 plus 2x. Now that is our constant rule, which is just kx, right, plus c. Because when you take the derivative of that, you go back to 2. And then we can't forget our plus c. Okay, so I'm just going to move this up here and simplify it first before using my initial condition. All right, so what this gives me is x cubed, and then the 3 and these 3 will cancel. Okay, I've got minus, this is going to be 4 over 2, which is 2x squared, right, plus 2x plus c. Now, I know this equals my original function. If this is the derivative that was inside the integral, and again, we can write it up here, f prime of x dx, right? That means that this, in fact, equals f of x, right, plus c. Now, I actually want to find f of x. So I'm just going to use this initial condition where x is equal to -1 and y is equal to 4 here. I'm going to substitute in and solve for c, and then my last step's rewriting it as an equation, okay? So 4 equals -1 cubed minus 2 times -1 squared plus c, and that's what I'm solving for. So it's got 4 equals, this is a -1, this -1 times -1 is positive, so we keep that -2, and then this becomes -2 plus c, so we've got 4 equals -2, 3, 4, 5 plus c, so c is going to equal 9, right? And so when I solve for my differential equation, I'm actually just looking for my original function. So I'm going to take this, and then I solve for c, which is 9. So instead of writing c, I'm going to write 9. And there's our answer.